Hello guys, welcome you all. I hope all of you are fine and doing good in your studies. Today I came with a question on topic center of mass. At first glance, this question looks seems pretty much easy. So I would suggest you to solve this question by pausing the video and check your answer. Okay, so as you guys have tried it, many of you guys will get answer L by 2 comma L by 2, which is wrong. And pretty much it seems like L by 2 comma L by 2 should be the answer. Why this is not the answer? Because in question, if you read this question carefully, you will find that it's clearly mentioned that these rods are of different material. What does it mean? A different material means there is non-uniformity in system. One rod is of density rho 1, then another rod is of density rho 2. It means we can't directly do it by symmetry that so its center of mass is, let's say, 0 comma L by 2 and center of mass of this is L by 2 comma 0. So you can't do like L by 2 comma L by 2, like XUM is L by 2 and YCUM is L by 2. This will be wrong since density is different. Okay, if density is different, we have to do it like, I will show you two methods for this. So method 1 is a very general method. Some of you guys may have did tried the question with this method only. So let's discuss. So here I am finding XUM of system as, so for finding XUM I will take, let's say, mass of this rod is M1 and mass of this rod is M2. So from here M1 into L by 2 plus M2 into 0. Why 0? Because x coordinate of this rod is 0 divided by M1 plus M2, and similarly YCUM will be M2 L by 2 divided by M1 plus M2. Alright, so from here now how to proceed further. I know some of you guys came to this conclusion that this should be center of mass, but you didn't know how to find exact option. So here we have to use brute force, like we have to satisfy each option in this equation. So let's say I am satisfying L by 2 comma L by 2 for this equation. So L by 2 is my XUM and L by 2 is YCUM. So I am putting XUM as L by 2 in this equation. So if I put L by 2 as XUM, then it will become M1 L by 2 divided by M1 plus M2. So from here L by 2 get cancelled out and I will get M2 equals to 0. If M2 is equals to, the condition is if XUM is L by 2, then M2 should be 0. And further our YCUM is L by 2. So I am putting L by 2 in place of YCUM. So M2 L by 2 divided by M1 plus M2. But here we got M2 is equals to 0. So here if I put M2 is equals to 0, then L by 2 will be equals to 0. And hence this option is incorrect since L by 2 can't be 0. Okay. So this option is incorrect. As I know the answer for this question is D, L by 3 comma L by 6. I am just showing you by putting this option in these two equation. So let's say what's our option D? L by 3 comma L by 6. So in place of XUM I am putting L by 3. So L by 3 should equals what? M1 L by 2 divided by M1 plus M2. So by solving L will get cancelled out, and we will left with 3m1 equals 2m1 plus 2m2. Okay, so from here m1 will equals to 2m2. Okay, so if m1 is equals to 2m2, YCM is L by 6. So YCM is L by 6, so L by 6. Okay, wait. YCM is our L by 6. So L by 6 should equals m2 L by 2 divided by m1 plus m2, and we get m1 as 2m2. So I will put m1 as 2m2. So L by 6 equals to m2 L by 2, 2m2 plus m2. So from here, as you can see, L by 6 equals to L by 2 divided by 3, which is L by 6 equals to L by 6. Okay, so this option is satisfying our both condition which I've got by solving generalized center of mass, taking mass moment of about origin. So hence this option is correct. You can do for another other options also, and may find that condition will not get equal for both the equation. So this is the method 1, and very common method. I am showing you a fast and simpler looks simpler, but you have to understand what's going on. So method 2 is method 2. Okay, so as we are having the system of two rods here. Okay, so here it is having L by 2, and this is having 0 comma L by 2, this is having L by 2 comma 0. As we know from definition of center of mass, what's the definition of center of mass for a system? That center of mass always lies on the line joining each particle of the system. You all know that center of mass of a system, two particle system, is always on the line joining the center of mass of individual particle. Okay, so I know the center of mass must lie on this line. COM must lie on this line. Okay, now I just have to find equation of line. So equation of line I am using as L by 2. So tan theta will be -1, as it is making 135 degree. And what will be the intercept? Intercept is positive L by 2. So equation will be y is equals to -x plus L by 2, right? So from here x plus y is equals to L by 2. This is our line on which center of mass should lie. Line on which center of mass should lie. Now just you have to put one option at a time in this equation. You will get, if the option satisfies this equation, it means that option corresponds to center of mass. So I am just showing you by putting L by 3 comma L by 6. If I put L by 3 plus L by 6, will it be equals to L by 2? Definitely. This will become 2 times 2L by 6, and 2L plus L will be 3L. 3L by 6 is definitely equals to L by 2. So in this way, the method 2 is relatively faster and relatively easy if you understand the concept. So concept is center of mass of two particle system always lies on the line joining the two particle. Okay.